So just to give a brief background, right, after passing out from VIT in 2018, in the final semester, I joined Intel as an intern, where we worked on smart cities solution. Our project was then adopted as you know, the national standards for any smart cities in India. We deployed in multiple cities that includes Pune, many cities in Karnataka and Kerala, and so on. The impact of that project will then be that any smart cities that will ever be created in India will follow that standard. So that will be the base standard for it. So I will be trying to cover a few topics related to that in this topic. Uh, in this presentation, the next project that I worked on was on artificial intelligence for the edge devices, that is the edge AI. Uh, Great impactful project for Intel. I hope by the end of the session you will understand that what we mean by at the edge and why it is important in so many use cases. So I was one of the initial members to work on this for Intel. We presented almost worldwide to even people like Shantanu Narayan or Andrew Ng that you guys might know of. So and this is something that is being pursued even in their labs. So just to set the context that how critical people are looking at uh, for the at the edge devices, and how IoT has now transformed to the next level, that it's not just about Internet of Things. What are people expecting in different sectors, and the different research work that is happening in labs around the world. So that's the second thing I was associated with. The third project was when I was, amongst the founding members of our healthcare project in Intel India. Uh, we deployed in several hospitals. Even there, the concept of edge was at the prime. I'll again, as you follow the session, you will understand that why in these segments something on premise or on the edge is much more important than going on the cloud. I will cover that. So, but that was the third project, and the project I am still working on. Uh, we are so that project is currently used for, along with CSIR and IIIT Hyderabad, to provide faster and economical COVID testing for India. So if you type on Google Intel plus CSIR anywhere, it will be flooded with PR news. And that's my project where we in a 3 to 4 members team built it. So just to set the context, so if you see it ranging from smart cities to healthcare, how it has all been uh, the concept of AI at the edge is at the heart of it. Along with the session, maybe you can follow it. Uh, there might be some latency, so I'll slow down whenever I'm changing the slide. Uh, but if you think that the slides are not changing for a long time, please let me know. Uh, this is just a notice. Okay. So very simply, right, what is AI? Just to set the context. Luckily in VIT, I think we all have electives on AI, so you have an idea of it. But how I see AI is more or less to think of it that AI is a technology that at the best mimic human perception. It cannot be same as what we can do as humans. Of course, the goal of the AGI is that it is generic enough that it can do it. That we can have AI twins. That for every person there is one AI device. But I think it's a long way to go. So right now, I think that AI is a technology that at best tries to mimic human perception. Why this sentence is important is that you can understand that though it is not good enough to take decisions on its own, but it can be an excellent assist. What I mean by assist is that it cannot replace humans. For example, in healthcare, my project always talks about that AI is not going to replace the doctors, but it will replace the doctors that don't use AI. Because the ones using it, the ones well versed with it, that how to use it, can make their task much simpler using these technologies. So AI as an assist will go a long way, in my opinion. So that's the only thing I would like you to take from this slide. Uh, why AI is very important. What was the need for it, and why do we need it now more than ever? Uh, I'll walk you through a few examples. So simply think of it, right? For example, right now I am taking the case of India. But this is more or less true in most part of the world, right? So if you think of it, there is a lack of teachers. So education can't scale anymore. There are two links that I have posted, and the numbers that it shows is that 8.5 crore kids in India don't go to schools, and out of that, around close to 80 lakhs are actually working today. And the ratio of teacher to student ratio is very very poor. And it's sad that in more than 1 lakh schools in India we have only one teacher teaching the student. uh, so you can understand that how education can't scale anymore, and no one actually is working on the grassroots levels. If you even think of startups that is coming in the edtech space or the MOOCs are more or less for specializing the already skilled. So it is for upskilling. I don't think it is solving a global problem of universal education. uh, Again, if you take example of something like the newer age startups for kids, it is not really for the underprivileged or grassroots levels. It is just money making business, which is again creating a new hobby in front of students. If you again follow Intel Plus education, so you will know that our team was responsible for creating a curriculum with CBSE, and we just last week created a Guinness Book of World Record of teaching 13,000 kids at one time on the basics of AI and how we can take it forward. uh, so that's one of the work that we are doing to make some changes of education in India. uh, but you can see that this is one of the fields which is crying for help with just any technology that can help us, AI being one of them. uh, the healthcare segment is the next. uh, India has a patient to doctor ratio of 1 is to 1681. That is very poor, and like, to be honest, a number that was released 2 to 3 years back. From what I hear is right now we have a doctor to patient ratio of 1 to over 2000. So for every 2000 patient at any time, and this is not the population, it's not like one doctor for every 2000 person. For any 2000 patient that is there right now in India, there's only one doctor to see him or her. uh, Estimate says that by 2034 India needs 3 million more doctors, uh, which is impossible, right? We cannot magically produce 3 million more doctors in the next 12 or 13 years, because there are so less seats in the medical colleges that India on average produces close to 25,000 to 30,000 doctors every year. And this is not even, I'm not even talking about the skilled professionals. If you think of brain specialist or something as such, the ratio is not even 1000, 1 is to 2000. It's even worse. uh, Even for beds, India is 1 to 1000, like one bed is available for every 1000 patient, whereas to take a benchmark from Japan, there's one bed for every 35, which itself I don't think is good enough. But you can see that why these problems are even more specific to India, because in terms of numbers we are doing very badly. uh, One last example will be the broken transportation and logistics. Uh, I have taken an example of Bangalore because that's where I've been based out of for the last 2.5 years. Uh, and what we notice is that the highest average speed in any area in Bangalore is 18 kilometer per hour, and that is laughable in most US cities when we compare with our counterparts in the US. Uh, Something like 50 miles per hour is very common to them, and it's like okay, can it be even less than that? So our road transportation system is actually broken as well. So each of these things, right, we cannot put more human resources. So when I talk about, be it healthcare or education, or finally the road transportation itself, it's not just a problem of the manpower that we don't have enough resources. Other thing that it brings is that even to the people who are actually getting these services becomes much more expensive because of the supply demand. uh, think of it that what I'm saying is, maybe at a time there are thousands of patients who are not getting access to the doctors, because there are not enough doctors. But even the other 500 or even other 100 who are getting it much more expensive than it should be for a country like India, where the economics for medical treatment and the GDP or the per capita income is not matching. So it's just not creates a gap between the number of doctors required, but it even makes things expensive because of the supply demand. So what can help? So one of the things where AI we see is can have the maximum impact is basically it can help scale the scarce human talent and the resources to the next 6 billion. Uh, why I call the next 6 billion? Because out of the 8 billion population, close to 8 billion population that we already have right now, it is a very you know easy estimate that more than 75% of them are actually not having access to resources. We are all privileged ones where we can actually get whatever education or healthcare that we want, at least up to some extent. But it's a very safe estimate that at least 75% of the world population cannot do it. So AI as a assist, which I mentioned, that if we have say 1 lakh doctors right now, can the assist help make them as efficient as 10 lakhs doctor? We cannot create 9 lakhs doctor magically, but can AI make them more resourceful, uh, takes away the easy tasks that they do, and I'll cover again in the later slides that how we can do it. uh, so these are the segments I believe that uh, are the key market for AI, be it healthcare that I already mentioned, logistics that I mentioned, education is there. The three again, which are the next three where AI will be a key segment, is BFSI, all the banking, finance services, digital assistants. You can already see a lot of call centers and all the places where digital assistants have become very popular, and as well as connected vehicles. If you see automated vehicles and all those things, I will try to cover a few things of what we have done in that space. But these are the six segments which I think will where AI will play a huge role going forward in the next 2 decades. So any questions so far before I start the next section of it? Maybe if you have any questions, feel free, and feel free to ask as many questions as possible. These same slides I can cover in perhaps half an hour to 3 days, so I can cover it in the time frame. It will be better if we are very very interactive in the entire time. If you have suggestions, if you have questions, if we don't agree to something, that is the best way to learn, right? Disagreement is the best way to learn for you and me. So please feel free, even to Maheshwari ma'am, I would request that you request all your students to keep asking question in the middle of it. That's the only way we can take something out of it. So if there's any questions, please let me know. I'll pause for a minute.
Mashrin, you kindly proceed. Mashrin will address all the queries at the end in order to avoid further delay.
Okay.
Thank you.
So okay. So I'll start with the next segment of it, right? Like we understand that why do we need AI and which segment needs it. Uh, so now I'll just talk very briefly about what is a typical AI development cycle, where what that we as well as most in industry and academia follow. Uh, this is again very very abstract to keep it as simple as possible. Uh, but at the very minimum, there are four different stages in the AI development cycle. It starts with import. Import basically means is that you acquire the data, uh, organize it, very similar to the data mining and data warehousing. I don't know if that course is still there uh, at VIT. At least in our time, it was there as an elective. So you can think of it that that is one of the courses where you can think of that how you can acquire data. I know in colleges a lot of time we just go and download publicly available data sets, which is good for practice, or to or for getting started with. uh, but in most cases, once you reach the industry or the academia, right, where we are actually making for the next set of problems, you just don't have to solve, you have to find the problems and find the data which is relevant to that problem. So you will almost at no times get a already curated data set. uh, So data acquisition becomes a very important role. I would say that it is at least by itself 30% importance, and that's why there is so many of data mining job roles itself, where the job is just for you know getting the data, preparing the data set, cleaning it, curating it, and organizing it well for data scientists to use. uh, Creating the models is the second part. When I hear a lot of interns, so we have hired a lot of interns from VIT as well, but uh, when I see my juniors or any interns coming in, right, AI to them is just limited to creating the models, which is not true. You will not even spend 20% of your time you know actually building models. So I believe that we give, it is important, it's very important at the end of it, definitely, but that's not the start and end of AI is what I want to convey here. And you need to learn all the other skills as well. You will have to make sure that you understand all the other things as well, because those things are equally important, if not more important. uh, you will not be creating more than 4 to 5 models at max every year, but to getting to get richer data and everything. And again, I'll tell you why edge plays a important role there as well. It is very important, so always keep that in mind if you're looking for data science roles going forward. So creating models is basically talking about you create your architecture. uh, Either you use a pre-trained model like ResNet, GoogleNet, or something as such, or you create your own architecture that, okay, I'll use this convolution layer at this time, followed by whatever, you know whether you want to use softmax or any activation layer. So you decide on what best you think uh, will be for your use case. So that is more or less the model architecture that you decide. The third thing is actually then training this model that you built in stage 2 using the data that you acquired in stage 1. So basically here you train the model, you change your learning parameters, and then the most important thing is deploy. You have to deploy it at the end of it. Again, the second example that I will give is that most time when people talk about AI, they talk about AI training, which is not true. AI training is not even 10% of the work that happens in any global AI product. It is always 90% inference and 10% of training. Even 10% is a high number, it is not even 10%. When I talk about inference, I think most of you will know it. But inference more or less means that okay, you have trained the model, but now you are deploying it for the end customer so that they can use it. To give an easy example, something like Alexa or Google Home, the model which can you know detect your voice and give you the output, training that model is what comes in the build and train stage. That is not even 10% of the task. Whereas deploying it to the end customers, to the billions of customers, millions of customers using it around the globe, uh, every time they use it, the model is being inferred. So that's why I'm saying that inference is the key. uh, it is not given any importance, at least even when I was in college, I never given importance to it. Now I realize it is much much more important than training, and you will again know why in the later slides. So this is where you integrate your trained models, and uh, with your things, either you deploy it on the cloud, in the edge, or wherever. So that's why I mentioned here that in the deploy stage, artificial intelligence on the edge can be used to infer the models. So this is a very important slide to remember. I think both as the picture as well as the 3 points that I mentioned, that importance of data acquisition, the high importance that we give to create building the models, and the low importance that we give to inference. I think if there's one thing I would like you to take out of this session, it will be this: that you start seeing it from the angle of inference and data collection as well. It will set you apart from your peers, because a lot of time there's only a bias towards, okay, I'll build the models, I'm great at training the models. So that can be your you know differentiator. So keep looking for that. uh, Now, to start with the edge artificial intelligence, right, I'll now start on the actual topic of what we mean by edge artificial intelligence. uh, so you know think of it like, read every word of this in the sense that imagine if human beings were like sensors. We are sensors at the end of it, but think of it as a very high level, or a basic sensor, right? So think of us as sensors, and it's not that hard because we have the tongue, eyes, nose, skin, and ears. Think of each of it as the five basic sensors for us. Uh, uh, so just think of it that these are the five basic sensors. And now imagine if our intelligence or our body worked in the way we process information today. What I mean process information today is the cloud method. I'm not, again, just a disclaimer, I'm not saying cloud is bad. It is amazing, and in a lot of use cases it is the way to go, and we use it as well. But uh, since since the time cloud exploded this big, right, we make every problem a cloud problem, and that is wrong. A lot of use cases don't need cloud, and it is bad if they're following the cloud. And even more important in the world of IoTG, so I'll cover that. So think of it as these five as your basic sensors in your body, that these are the basic sensors. These are the five sensors that you have. Now imagine that our body or our intelligence work the same way we process information today. uh, now imagine in this sense that you were walking down the stairs or something, and you were falling down, okay? But to register, to know that you're falling down, you had to send the data to the brain that was somewhere in the cloud or a data center, and then the brain from there will come and tell you that, oh, you know what, you are in trouble. uh, the latency that this will include, right? So this is basically, when I talk about cloud, it is more of, we talk of as a master slave thing, that cloud is your master, everyone else is just a worker node which is sending information to the cloud, which is intelligent. So this reduces cloud to be the only intelligent part in your entire system, which makes the system very prone to failures as well as latency. So again, as I said, right, for very quick, knowledge or very low network latency, that I want to know it on spot. If our body used to function like we function in most use cases right now, we will be in trouble, because it will take so much time for all the sensors to send information to the cloud and then get the information back. Uh, so network latency is a big issue. This is just a example that I've given you, but in a lot of use cases, you will agree that how network latency is very, very critical. For example, again, to give a real world example, if you are driving an automated driving car, and if you detect something, if you keep sending every information to the cloud and wait for what I have to do given this environment. For example, if a car is coming in at a very fast speed in front of you, and if you keep sending this visual data to the cloud, to get that, okay, tell me what should my automated driving do? Should it apply the brake? Should it go to the side? If there is even 1 second latency extra in the transfer, you are in trouble. There will be an accident. So network latency is a very, very important issue. Many segments need less than 1 milliseconds of network latency. So to take away from this slide, network latency is an issue, and it is very important. uh, uh, just 1 second. Okay, so two more very simple example, right? That imagine you were riding on a boat in a lake, uh, and suddenly there's no connectivity to your brain. So isn't it dangerous? uh, Again, this we are following the same principles that we discussed in the last slide. Brain more or less mentions the cloud. So again, think of it in a way that okay, if we keep processing the information in this way, if there is there's a connectivity loss, and you are in middle of something critical, what will you do? It will be very dangerous. You can again take the example of an automated car or something as such. So if you see to it, connectivity is very important. And right now in a country like India, even 3G connection is not reliable. And this is true for most developing countries. And if it is true for most developing countries, it's true for 80% of the world, that connectivity is a challenge, it's a key issue, and it is very important as well. So if we are making global solutions, if we are creating solutions for the world to use, we have to be very, very careful that we are not just creating for the rich or the top 5% of it who have great connectivity at 99% of the times, but we are actually designing it in a sense that it is the solution is as foolproof as possible. uh, so connectivity is a big thing that you should consider when you are designing your applications. The last point, imagine you have a Nobel Prize winning idea, or in your context any idea which is very important to you, right? And someone just took the central control to your brain. uh, think of it in this way, that you had great projects you were working on, everything was on the cloud. All you need is that that one security intrusion in the cloud, and all the things that you have done so far is over. uh, Point to take from here is both security and privacy are very, very important. I think in India people have slowly started realizing the importance of privacy and security, but it's still not there, right? I see that we lag behind it. We don't care about our privacy and security much, especially the privacy part of it. But that is not true for uh, you know other countries around the globe. People are very, very serious about their privacy, uh, and it should be. I think in India as well it will happen soon. Uh, so if you think of it, that first, in the first section I covered to you why artificial intelligence was important. In the these two examples that I am showing, it is artificial intelligence. Your body is our intelligence system. So AI is already there. So we have already reached one level from no AI to realizing that we need AI. Now in the two slides, what I am trying to say is that even the AI that we have right now, it needs to be made more intelligent. Uh, Reason being, the network, latency, connectivity, security, and privacy are all very, very important things, and edge AI will play a huge role in it. So okay, so what is edge basically? Now we come to this point, right? We uh, finally discuss what is edge. Uh, so so far, to different people, they will have different assumptions based on what they think the edge is. Is it the outside limit or the corner of any object? Is it the sharpened side of the blade which you use for cutting things? Is it the border or the edge, the lead guitarist, device outside data center, terminal network node? So if you have already not known edge, these are the common synonyms of edge that people usually identify with. That if I talk about edge, the first thing that will come to their mind are these things. Whereas edge AI basically means that your AI algorithms are processed locally on a hardware device. What I mean is that if you have a smart camera, your algorithm should run on that smart camera. So that means it is running on the edge wherever your hardware is. It is locally running. It is not sending all the data to the cloud and then get that information back and then make the decisions. Uh, Again, I told you about why in a lot of use cases, what are the different reasons that it doesn't work, that we keep sending data to the cloud and get it back. So edge AI, again, to reiterate, means that your AI algorithms are processed locally on the hardware, and the algorithms are using whatever data locally the sensors are seeing. The algorithms are quickly processing it on the edge itself. So you can think of it on the device itself. So if it's a laptop, your AI should run on the laptop. If it's a camera, it should run on the camera. And now you will understand that why it is so much importance for IoT. Because IoT is one of the only segments where each device are low powered, but it is in huge scale. If you think of even traffic camera, right, there will be thousands of camera on one road, one stretch of the road itself. No other segment except for IoT is having as many devices as IoT has, because IoT has small devices but a lot of devices. Especially in case of the Internet of Things devices, right? It is very, very important that we make the critical processing on the device itself, and only the second level of things. For example, you have already detected it, but you want to save it in the cloud, then you still save it in the cloud for your later uses, or to train your model against the real world data. But the main important things should be processed on the edge. So if it's a car, there should be a compute unit inside the car which processes it. If it's a hospital processing healthcare data, there should be a small device inside the hospital which makes all the critical things which is needed in real time in that hospital premises itself. So that is what we mean by cloud. If you think of it, all the sensors send the data to the same device itself. And if you see the first 2 points, right, the sensors device, the actuators, and the analytics decision making edge, they are both interconnecting, right? It will keep sending data to the edge and it will keep showing, giving back the action. It's not like the device is sending it to the cloud and then giving the information back. So this will keep communicating only for any notification. For example, for example, think of it. You are getting the data for any, traffic data. You keep, diverting the traffic based on it without connecting to the cloud. So in minimum latency real time, you are providing it. But just in case some accident happens, only for the use of notifications, you send it to the cloud, which can then send it to the hospital and all the things can be provided. But if you think this is, this is retrospective, this is happening after the event has happened. Edge should be used for anything that is proactive, that I want it real time. And then whatever can be done after the incident has happened, or which is not required for a real time thing, you send it to the cloud, which can then send it to your different partners, that okay, there is an accident, you need to help and all those things. And then those actions it will provide back by sending the ambulance or anything as such. So this is how the edge AI architecture on 1,000 feet level works. uh,
Excuse me?
yes, yes, please.
Yeah, I actually understand the importance of edge AI. That's
Mhm.
it's very much important though. But just imagine if every end device has to be that intelligent that the algorithm has to work on that and it has to process information. And if you use the cloud only for storing the data, will
Mhm.
the size and cost of the end devices doesn't increase? Like, because if you make every camera out there on the road intelligent, it automatically becomes costlier. It needs higher processors to it. And
I'll Makes sense. I'll cover that. I do have that in my segment, that what is being done around the world. I'll give you some examples as well. Again, we had some recent news with NASA where we even sent it to the space, about the chip that I'm going to talk about. Uh, so yes, very valid question. It's a good question. Glad that you asked, because I'm going to cover that in the later slides, at least on the technology part of it. So you asked basically in three portions. One is cost, second is the size, which is the form factor, and third is, I think, these are the two things you mentioned, right? Or is there anything else I'm missing?
yeah, the same.
Okay. So for the and the processing power, right? So I'll cover the processing power as well as the form factor in the coming slides. I think the last segment of my talk covers that. To tell you about cost, right? Since I've not added cost, anything related to cost for our technical audience in this slide, but I'll answer it right away then. The reason why cost will still not be a huge factor, right, is because anyway you have to process the data. So if you are a company which is a road corporation, you have to pay money either to the cloud providers or you do it on the edge. I do agree that if you're doing it on the edge, your initial cost is higher, but at the end of it, even if you're doing it on the cloud, you'll have to pay for it. It's not like you are getting the cloud services for free. uh, so and research says that edge devices actually has lesser cost over the time. I'll give you one reason. You are sending less data to the cloud. uh, so it's not just about processing power. If you are going to process it in the cloud or on the edge, I agree, initially on the edge the initial cost will be high, but the cost of processing it will be same, because that data has to be processed at one place. But why it will be actually more expensive in the cloud is because in the edge you are not sending that huge data to the cloud continuously. uh, Whereas for a cloud only ecosystem, you have to send it. So you are saving your bandwidth cost. We don't realize it because we are using very cheap internets. Greatly because of different companies trying to get more customers. But the cost of internet is cheaper right now for the B2C, because they want to acquire the customers. It is not the case in B2B. The cost to transfer data is very, very high, almost equivalent to the cost of processing itself. So that's the reason why running it in the cloud is actually uh, in most cases more expensive, because it's just not processing, you're transferring data as well. Regarding your the power requirement, the form factor, the size of the device, and the processing, how we'll do it, I'll cover it. Okay then.
Yep,
So
yep.
the key
Thank you.
challenges. Yeah, good question. Keep asking, please. Uh, just a second. Okay. So the key challenges, if you think of it, right? We have already covered this. Just to reiterate before we move to uh, next segments. Uh, so computer vision solutions, if you see, often experience bandwidth, storage, and video limitations. We already covered that. If it's a HD camera, just imagine thousands of different cameras sending everything to the cloud in HD or 4K space. That's one of the reason why we have why we don't have high quality cameras in most of the use cases, because it becomes very difficult to transfer that huge amount of data. uh, the second challenge is that how can we improve the our existing algorithms to improve their performance on the edge itself. uh, then it's just about applying software to different hardware requirements, so that we have a complete solution redesign, that from how a cloud only we are moving to a edge plus cloud, and then how we can scale it for actually creating an impact. So these are the key challenges of 4 bullets that we can think of. uh, but from a IoT endpoint, you can think of it as these things, right? The IoT endpoints may not have the communication capability to transfer all their sensor data in a very secure, reliable, and cost efficient manner. uh, to the core, but by to the core, I mean to the cloud or any central system that you have. uh, and you will agree to this. I think you will agree that in most cases it is very difficult that all at all your locations, wherever your devices are present, you have a very good internet or a bandwidth connection that you can send all the data. Security, reliability plus to it, it's very difficult. There will always be a man in the middle attack. No matter however foolproof your solution is, there will be a hacker who will be smarter than you, uh, that will try to get the information piece of data. The reason why it happens is, since you are sending it from your from your local environment to the cloud, it gives them enough opportunity, enough points where they can just mimic to be the correct device, but they are not, and they can get all the data. So it's a big challenge in terms of that as well. So the common obstacle of this is, right, sensors may only support low energy protocols to conserve battery. uh, the mobile devices, even the mobile devices that is having cellular communication, lack coverage in certain locations. I think forget certain locations. Right now I'm in Mumbai, and half the places in Mumbai I don't get a proper 3G or a 4G. So just imagine the case in most places, right? uh, Mobile communication links are often bandwidth constrained. Even the fast internet that you are getting is only up to a limit. It's not unlimited. It can never be unlimited. And in a typical B2B kind of a thing, where you are actually doing it for business, the communication cost is very high. Like, it's tremendously huge. uh, Wide area connections can introduce latency, though it can you can create a wide area network of all the devices that you have, so it is off the internet, but creating that will again have a lot of latency. uh, Again, to take the same example, certain local system like the self-driving cars must autonomously make decisions in real time and cannot wait for the instructions set to the cloud. Uh, so very simply, why do we need edge AI? These are the 6 most important points. You need quicker response, low latency. You need better security and privacy. Uh, you need, you have to understand the data volume versus the available bandwidth. Available bandwidth is not much, but if you send all the data, the volume is high. You need to lower the communication cost. You need to reduce the dependency on network, because if something fails, you don't want everything to be stuck, right? Like, you might have seen that in Mumbai, I experienced there was a grid failure and the entire city didn't have power for 5-6 hours. If we are aiming for a world which is very intelligent with AI everywhere, we cannot let that happen. If that happens, this was no power. Think of it as, and having no internet too is a very common thing that we are prone to face, right? uh, So there is lack of availability in a high availability world where we want everything to be available 24/7. That's a huge risk. And you know doing things on the edge actually consumes power for you and improves the battery life. I'll tell you why, because maybe you can even read that communication, sending the data and communicating with a different device involving the pings that is there, usually takes a lot of battery. And that's why when your mobile data or even the mobile network is on, it takes much more power than being in the airplane mode. uh, so okay, so next slide. So why should you care about it? By 2020, the average person will generate 1.5 GB of data a day. uh, I think we have crossed it, thanks to Geo, at least even in India. Given the 2 GB data limit that we get, uh, we I think each of us on an average consumes 1 GB of data at least. Think of the corporates and all, the amount of data that they generate. If we divide it by the 7.5 or 8 billion population that we are close to having, uh, we generate more than 1.5 GB of data a day. That's a huge data. I think even 2 decades back, thinking of 1.5 GB was a huge task. But we are still following the design principles of a decade or two, which are a decade or two old, which was not created or built thinking of the data explosion in mind. A smart home typically uh, connect 50 GB of data a day. A smart city, I'll tell you from my personal experience, is I think there are cities which generates more than 250 petabytes of data. Petabytes is something that again, till a decade or two back was just a term in the textbooks. We never saw it in real world. We never thought it will happen, but it has happened in such a close time, and it will only keep increasing. uh, Gartner projects that the IoT devices will climb to 50 billion by 2020. As I said, that IoT is actually one segment which is having the most number of devices, small but a lot. Uh, so yeah, I think we'll cross 50 billion, with everyone getting new cellular phones and everything. The way we are expanding, I think we'll cross 50 billion very easily. Uh, Another research shows that the shipment of device with edge AI capability. This is a very important point, which even for your technical growth, or for your career path, I'll mention, right? Usually it is not a point I mention in conferences that I take outside. uh, but since you'll all get into industry soon enough, you need to understand and pick your fields and bet on technologies which you think can have maximum growth. Don't just keep saying AI just keep saying AI data science, and they'll keep joining the same line. But you have to understand, AI is a very huge term. What in AI, what you want to bet on, in which segment you want to upskill yourself, so that you can make a great uh, contribution to it. And there will not be many people working on that. People say that there will be 1.2 billion new devices which will have edge AI capability. I am a very strong advocate of that. It will cross this. I'll tell you how many devices that you already know, uh, in everyday uses, is already having edge AI capabilities now, which was not there till even 4 years back. uh, the share of AI task that takes place on the edge device instead of the cloud will grow more than 7 times. It was 2017, and it was 6% in 2017, but people say that it will be anywhere in mid 40s by 2023. So you can think of it that by the time you graduate, 2023 is when I think you will graduate, if I'm not wrong. But I'm not sure, right? So if by the time you graduate, close to that, more than 40% of the device is actually running things on the edge. So everything you are studying, if you're not considering this, the curriculums takes a lot of time to change, and there's a good reason for it. But you'll have to upscale yourself, because this will be the real world scenario very soon before you realize it. So that's why you should care. When I mentioned about you, I think why someone, my fellow students from the same college why they should care about AI is this reason. So this is where I'm telling you about that, why you should pick that, if you want to go into AI or IoT, pick something either related to the security part of it, privacy part of it, or start working or designing on edge AI. Publish something on edge AI. It's very, very simple. It's the unexplored field. Everything that is there right now on the cloud, you just need to redesign it to the edge and it will become a publication. It is that easy. But you need to show that capability, and that's why you should care about edge AI even now. uh, in terms of segment, for example, few of you might be related, more interested to mobility, something like cars and automobiles. Interest you, some might be working on the communication sector, that I want the latency to be lower. I am more passionate about the mobile communications and all those things. Few might be in robotics, that I want autonomy, or autonomous driving, or any robotics. Few of you might be interested in security. Few of you might be interested in just simply all the other AI ML application. uh, I can send this picture later to Maheshwari ma'am. She can send it to you. I would like you to have a quick look at it. This basically talks about all the industries. This basically talks about all the industries that manufacturing industry, automobile industry, smart buildings industry, the consumer IoT, which is the smartwatches, the entertainment industry, transportation industry, smart grid industry. So it is very, very likely that you will start working in one of these 9 segments, that one of these 9 industry sectors. I personally believe that close to 80 to 90% of you will work in one of these things, when you get into industry. uh, so you need to understand that for your industry of choice, what is the need which is most important. For example, for a WAN network bandwidth, if you are very interested in WAN network, it is, then maybe manufacturing is not a segment for you. You will not get a lot of opportunities there. Then you should perhaps look at the entertainment industry, that how we can make the content deliver much faster. So this is just again for you, that you can see that why you should care about edge AI. The reason why I'm telling about edge AI is all the needs that I have mentioned and all the industry sectors. So all the needs which are rows and all the industry sectors which are columns, all uses edge AI now. But you, even to drill down one level deeper, right, you should try to determine that based on the segment that you like, what is the most important things, and in which segment of even edge AI you should work on. So it is again one level deeper down, that if you want to be very specialized in. Uh, so last point before I actually get into the technologies that enable this, just to reiterate all the points again, that vision, even in AI, vision is something which is driving artificial intelligence at the edge. uh, Everything else, if it is sensors or street lights or something as such, people are finding that it's still okay if we are getting some 3 to 4 seconds of latency. Think of it that you have low lights, but if you get, if your street, hello, hello.
Yeah, yeah.
Mushroom, that's an external disturbance. You kindly proceed.
Okay, yeah. So I'm saying that especially in the case of vision, uh, AI at the edge will be the most important. uh, the next slide will start more or less with the technologies of what one person very nicely asked, that how we can do it. uh, I'll talk about it, but before that, if there's any questions. I didn't get it. I heard a voice. I don't know if that was a question or anything, or if that was an instruction. I missed that, sorry.
Mushroom,
Yeah, ma'am, yes.
it's an external disturbance. You kindly proceed here.
Okay, thank you so much. So I'll now start with that. So we have now all discussed about so think of it, just before we get into the next segment, that why AI was important, what are the key segments where I think AI is important. Then we discussed about that, why AI needs to go one more level up to become more intelligent. Then we talked about what edge systems are. Then we discussed about scenarios or segments where edge AI is even more important. Like, it can be used in many segments, but what are the specific segments where it is even more critical? So that is what we talked about. Then we talked about that, you as students are currently skilling yourself for, jobs or academia, why you should be concerned about edge AI. Now we'll get into the depth of it. I've tried to keep it as brief as possible so that, I don't over confuse you. But we'll talk about, what are one or two ways of doing it, that how we can actually make all the things that is currently on the cloud or which is not smart to run on the edge. So we will show you. I'll discuss that in brief. If you have any question, all these materials are open source. Feel free to read it. I'll be happy to even answer it. But before I start the session, right, I'll just come in 30 seconds. I'll just have water and come back. Sorry for that. I'll be back in 30 seconds.
Dear participants, if you have any queries, you kindly post your queries in the chat box. So all your queries could be addressed at the end of the session. If you couldn't understand something, then you can unmute yourself, then you can raise your question. Thank you.
Okay, I'm back. When I look at the time, we still have 1 hour, so we have time. I think this will be the best place to ask questions before we get into the next portion of it. I would like that, whatever questions you have so far, let's clear them up so that towards the end of it, you can ask specific questions regarding, the two different things I'm going to speak about, because I think you will have a lot of questions there, or at least you should have a lot of questions there. So if there's any question, one or two questions, suggestions, your views, uh, or any question in general of, how, things look different once you step out of uh, academia, especially in terms of technology, feel free to ask. Let's, if you have any question, we can give that 5 minutes. If not, if there's no question in maybe a minute, I'll just start with it. But please ask questions.
How reliable is this edge AI? Because if every the sensors become AI, so if we have cloud, we can maintain one separate server for that, and we can ensure power stability for that. But if
Mhm,
every camera has this edge AI, so we cannot
mhm.
ensure power for every device, right?
Okay, yeah, makes sense. Fair enough. But I think you answered the question yourself. I'll tell you why. Uh, think of it in a traditional model, which is, uh, cloud as the intelligent node, and everything else is more or less just to transfer the data. Okay, think of it. So now you have a single point of failure. If your cloud goes down, if you have 1 billion devices, everything goes down. Nothing will work. So it's actually, uh, more. So the cloud system are actually more prone to failures, or at least in terms of single point of failures. The chance of one sensor failing is definitely much higher than one cloud failing, but the impact will not be much, right? Think of it that at one point, even if 5% of your sensors in a city fails, it's still okay because you have 95%. Whereas in cloud, if one cloud fails, and it is very easy, we think of something as a cloud as something like, it cannot fail. We see it all the time. Like, we have to provide solution with, 100% high availability, but it's very very common that, there will be times when, think of it as any cloud provider that you use, that entire region will go down. Maybe the entire India region goes down. It can be for any reason. And in that case, if cloud is your only intelligent node, if you have 1 billion devices, all 1 billion goes down. It's not like even, half of it or some of it will work, because everyone will keep sending data to the cloud but will not get any, you know, uh, any result back or any action decisions back from the cloud. And as I said that, it is very likely that at any time 5% of your smart cameras are not working, which is okay. 5% of camera is not working, that is fine, because I still have 95% of the cameras in the city which will always work. My point of failure is now not one but much more than that, so it makes it very reliable.
Okay,
Does that
so
answer your question?
what I knew is that like you say
Hmm.
Google Cloud or some Amazon Cloud, what
Hmm.
they have is that they have many data centers, and
Hmm.
if something like power went off in one center, the
Hmm.
data is spread along its cloud, right? So see, if they have a center at India and center at Australia, if
Hmm.
at Australia power goes down, the data will be still there on India, I guess. So it won't drop off. Like 100% of the devices, they won't respond. That thing won't happen in cloud, I guess.
Right and wrong. First point where you mentioned that, uh, that was the initial thought process between behind any cloud, but with all the different data privacy laws which are coming, right, the countries doesn't want their data to go out of their country. For example, the privacy law in India maintains that, every service that you are providing, the data should reside in one of the data centers in India. uh, Second thing, I think it's very common. You mentioned Amazon and Google, right? Something as big as Google. I have seen at least twice or thrice in this year that, the Gmail service itself was down for 5 minutes. That's a big thing. If 5 minutes everything is down, you are at a higher risk uh, than anything else. When you're talking about power, if you're saying that, the power of the cameras will go down, if the power of the cameras will go down, then it will not send the data itself. So even if a cloud is there, if it not gets the data, what's the point of it? Uh, but if the power remains, it can very well perform there. So the point of failures is, much more here, so that it becomes very reliable in that sense. Again, I have nothing against cloud, to be very honest, right? We have applications where we have both in edge and cloud, so I'm not saying that cloud is bad. I think cloud is amazing. In the last 20 years, that's the best thing in computation that has happened, one of the best things, to be honest. So I actually am a big advocate of cloud as well. All I'm saying is that, there is not a single correct answer or a single right thing for all your application or for all your use cases. You have to determine that, the only, yeah, so just to say, right, the only thinking process that I want to develop in you guys is, right, your default action should not be that, okay, I'll host this on the cloud. I want you to think one more time that, whether it should be on the cloud or it should be on the edge, and only the notification should go on the cloud. If you develop that thinking process itself, you will be in the top 10%, because people don't do that. It's very easy to just hear cloud, 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 because we have heard so much about it in the past. So cloud is still the number one for many use cases, but it is not in for a lot of use cases as well. All I'm saying is, based on your use cases, based on your use case, you have to determine the plus and minuses. For example, something like healthcare, no chance, no hospital will let you, transfer your data to a cloud. It's much easier to develop applications on the cloud because you don't have to manage a lot of things. When we were doing the healthcare application, not a single hospital, not even one hospital, even in India, allowed us to do it on the cloud, and it had to be on the edge. So for certain application, it is no brainer that it has to be on the edge, otherwise you will not be allowed. I'm not talking about the projects or capstone project or anything as such, but in real world, for some cases, cloud is the, the go-to option, and it should be used. But there exist a lot of things which is in the middle, that, it can be done on the cloud and on the edge, based on your use case and what you want to achieve, whether you want to provide it faster, or you want to maintain the security and the privacy. Whatever is most important for you, your use case, you will have to, use the correct approach. So all I'm saying is that, both the approach are brilliant approaches. It's just that, I just want to leave you guys away with one more approach, that it's not like there's only cloud in this world. There is one more thing. You just think of it as what I want to say, but it's not like cloud versus edge at all. It's cloud plus edge, choosing what is right for the best, for your use case. That's it.
Okay, thanks.
Hey, thanks for the question. Yeah, really appreciate it. Any other questions? Okay, if not, I'll move to the next section. uh, so again, what I am giving you as an example is something that I know. uh, and again, because most of the world edge devices is currently using that. So though it is from Intel, see, most likely if I was not from Intel and if I would not worked in this segment, I would have not known it. But if you search about Movidius and what it does, you will see that it's not because of my bias towards Intel. But if you work in the area of edge AI, chances are that 80% of the time there will be one single piece of hardware that you'll come across, and this is this. So that's why I wanted to cover this in this section. uh, Even if you don't understand the internals of it, it is okay. But it will at least give you an understanding of, as I mentioned before, right, that how even the non-smart devices can now become smart, and it can it can still remain small, but it can have the processing power to do everything on the edge. So think of it, Movidius, as just as one of the approaches to do it, which also happens to be the industry leading way. So okay, so NCS in that sense is a neural compute stick. So is my slides changed? Can someone just quickly confirm if my slides have changed and it is the correct slide? Can you
Yes, yes,
see
yes.
more
It is.
videos and yes? Okay,
Yes.
thank you so much. Thanks for confirming. Okay, so this blue stick that you are seeing here, right? The blue stick is what we call a neural compute stick. Okay, so I'll tell you what it does. Uh, you will understand just from the name itself, right? Neural compute stick. Neural stands for what you can understand it as a neural network. Compute is actually for processing, and stick because this is in the stick form. So basically, it means that any AI neural network which is there, this stick should be capable of performing, uh, what to say, any inference on it. Again, when I say inference, it means running. So when someone asked a very good question of how we can process it in these smart scenarios, this is where it gets processed. So what NCS enables is NCS enables you rapid prototyping. It can quickly help you prototype, validate, and deploy your deep neural network. And so if you think of it, right, so there are three segments. The first segment that I mentioned here is training. So what I say is that if you remember, I told you training is only 10% of the task. You train it once, you run it millions of times. Like each model, think of it the Google keyboard. The Google keyboard, if you think of it, is an AI model. It was trained, you know, once, given to millions of users, then again trained once, then again used by millions of users. So you train once and it is used at least thousands of times. So training is actually a very small part. So you train it anywhere, whether you want to train it in your data center on GPUs or you train it in the cloud. Again, it's a very good way to train models in the cloud. Because you can train it. Uh, so you train models in the cloud or anywhere you want. So I don't know how many of you have worked on neural networks or deep learning as such, but if you think of any uh, deep learning model, right, it consists of two things. One is the network graph. Again, the network graph basically means that okay, there should be a convolution layer, then it should be followed by which activation, what should be a softmax, and all those different things which is there. So think very top level, very briefly, it consists of two things. One is that network graph, that what is the graph of your model, and second is the base, the weight and biases file. So whenever you train your network graph with any data, it creates weights and biases. At the end of it, this entire you know deep neural network or any field is just maths. It performs a host of very complicated mathematics on top of it, and it creates uh, the weights and biases files. So if any one of you have worked with, say, TensorFlow, you will see all these .pb files and all those things, the protobuf files which is there. So what is the practice that people do is they train it anywhere, assuming that they train it in the cloud, then they take that model, and then so they download that model and offload it to the Movidius stick. One very important point, I think this will keep start coming in your in your heads. but I'd like to clear it right now itself. This is in the stick form only for the developers. Okay, so it is in the form of the stick just for people like me and you to develop. This same thing is actually available as a chip. It is available as such a small chip that it will become negligible, but it does the same thing. So we are having it as a stick because we can easily, just like a pen drive, carry it everywhere and you know create different prototypes and validate and deploy our models. But in real world it is a very small chip. So the person who asked, right, a very good question that he asked, that how we can make any device smart. All you need to do is you need to plug in is the word for USB, but you need to interconnect this small chip uh, with your IoT device, and that small chip will not make your device any bigger, and at the same time it will now become capable. So you can think of it as a magic stick where even something like a Raspberry Pi. And by the way, in my final year project I have done that and shown in VIT. On a Raspberry Pi we ran deep neural network, just because all the AI. So what this chip does is, once it is added to your any compute, right, even a low powered compute, anything related to AI that happens, in very simple terms I'm saying this, anything related to AI that happens, this chip starts processing it. So this chip is actually capable of processing all those things. So now you can process on the edge. At the same time it doesn't increase the size. So that this is what was the answer to the question that was asked before. So how it really works, right? If you think of the second picture in this, right, it basically shows you a development host. Here we have shown a laptop, but a development host can just be a Raspberry Pi or a smart camera, or sorry, or a basic camera or anything. But if you combine these two, right, if you plug this in, it become a very powerful tool. And you will be shocked to know, just a fact, right, 70% of the smart cameras which is there, or more than that, this is again I'm quoting a number of 2 years back when I was working on this, already has the Movidius chip inside it. uh, it has been there for 20 years. It has come as a chip just 2 or 3 years back, when around the same time when I was working on it. At that time it was made as a chip so that it can be, more developers can use it, because developer community didn't know it, but it was already happening. But now that we are expanding the edge AI world, right, we have this stick available on Amazon or anywhere as such, uh, to process anything, uh, a- process any AI workload on the edge. uh, so just to say, even the stick, it's a fanless USB stick form factor. It supports TensorFlow Cafe now. PyTorch is also supported. It's a slightly older slide. I forgot to make changes to it. Uh, so any framework is supported. I don't know if you know about ONNX. ONNX is basically Open Neural Network Exchange. What ONNX does is, if you like, say, if I like developing something in PyTorch, and Maheshwari ma'am might like developing it in TensorFlow, and one of you might like developing it in Cafe. So so be it any framework that we want to use, ONNX basically allows you to interchange it. So your neural network can interchangeably be converted to different frameworks. So if I develop in TensorFlow and later we decide that we want to make everything in PyTorch, ONNX can develop. ONNX can do it. So similarly, though the TensorFlow and Cafe was supported by default, even if you develop it on say any other framework, it will be supported. Uh, so it is usually used for prototyping, tuning, validating, and deploying deep neural networks at the edge. Uh, but again, I am mentioning prototype many times here is because this stick is only used in prototyping. It is only used for developers. Uh, in no real world use case, you will actually have a stick. Uh, think of it that you have a small camera. If you plug in this stick, it will become so much, uh, what to say. The size of the device will increase a lot. So no one in real world deployment use the stick. They use the chip. Uh, so now what is that inside this chip that makes it so interesting? So this basically internally has a Movidius vision processing unit. You might have seen central processing unit. You must have known the graphics processing unit, the GPUs. But what is, vision processing unit? Uh, it is, a bit complicated. I think, if you are interested, you can always read what is a vision processing unit. But for the sake of this session, just to keep it very simple, think of it as something between the CPU and the GPU. So basically, if you I don't know if you've already covered computer architecture, but the only reasons GPU are faster is it can do matrix multiplication very fast. And that's why you don't that's why you know that only in specific use cases like gaming or AI or crypto mining, those are the only two or three segments where GPUs are used, because you know they need a lot of matrix multiplication and graphics processing. But GPU can never, that's the reason also that GPU can never become the core part of your system, because it is not generic, it cannot do everything. Similarly, vision processing unit cannot do everything. It is not a computer or a CPU in that sense. But what it does is, rather than, so since GPUs are very expensive, right, think of it that if I want to make an application and if I want to add a GPU, you imagine that your device, your smart camera is $50, but to add the GPU, it will add $100 to the cost, because GPU is so expensive, because a lot of new applications needs GPU. That makes it very, very expensive. There's a lot of supply, there's a lot of demand, the supply is less. So that makes GPU very, very expensive. So if we wanted to add a GPU to uh, every smart camera or every edge device, it will increase the cost in such a way that then your product will become useless. Because if a customer is buying your product for $50, maybe if I make it a little more smarter, they will go to $60 or $65. But you can't ask your customer that, what, from $50 now I'll sell it for $250 because now I've added a GPU. They'll just say that, what the hell, I don't need your GPU, keep your product. Because 250 for for some products might not be good enough. So what vision processing unit does is, it just uses some components of the CPU, think of it in that way, and optimize it in such a way that it becomes very useful for anything to do with images. So if it has anything to do with images, it is by default that it will do everything good for the video, because video also at the end of it is just a lot of images, like 30 frames or 60 frames per second, but at the end of it, it's images. So if I modify my CPU in such a way that it can do well on any image related task, I am good enough. I don't need a huge GPU which can do much more, because for my application I just need a basic thing which can do everything very fast for vision related things or image related things. And that's why Movidius is used so much in all the drones, surveillance cameras, virtual reality headsets, and even low power intelligent and autonomous products. So you might not be knowing it, but already a lot of smart cameras or drones or your VR headsets already has this chip inside it. So it's not new, it has been there. It's just that a lot of work has been happening recently in it. So it's a good time to learn about this. uh, Again, something like your Siri or uh, Cortana, Google Home, Alexas, each of it, some of these are already having it, and some plan to have it. That uh, a lot of these things, unless it is required, can be done locally itself. So important point to keep in your mind that we never plug the stick in real world application. We use the chip. That chip is called Movidius VPU, or the even technical and the exact name for it is Myriad, MYRIAD, the Myriad chip. I hope I have it in some other slide, but that's the thing. Okay, I have it. So this is the architecture. So basically, it contains the Myriad chip, and it includes 4 GB of DDR3 DRAM. Uh, so again, so think of it in this way. Okay, is my cursor showing?
Yes.
Thank you so much. Uh, so think of it in the sense that you have a camera which was already there, And previously it was just, just a camera. How I can make it, uh, a smart camera? So here you think that your smart camera is now connected to this chip. Okay, this is like an application processor. Okay, so now your application, whatever you want to write, you write it in Python, C, C++. The reason why you need to write application, sorry, the reason why you need to write application right now is, so previously this application was also in the cloud, but now you want to run it here itself, right? So you have to bring your model and how you invoke the model here. So you bring it here, and then all the AI runs there. So you have close to 4 GB of DDR3 RAM, sorry, DDR3 memory. Sorry for that. So what it does is any in-memory thing which is there. For example, if your application needs some temporary memory, remember this is temporary memory. It's not a it's not a storage. It is never the storage since it is only for real world. That's why I said, uh, if you want to make anything for the storage, you should send a notification to the cloud. So, but 4 GB is a lot for continuous running of one single device. So it will keep looking into it. So if you look into the internals of the neural compute stick, right? So internally it has a Myriad 2 SoC. So that's a system on chip kind of a thing, and it has 12 shave processors. Uh, Again, I don't know how to explain shave processors easily, but you can think of it as 12 very uh, low powered vector processors. Think of it as vector processors. The reason to use vector processors, as I said, that's what GPU used to provide you, right? Your vector multiplication and your matrix multiplication was much faster. So if I create a low cost device which is able to do just that, if I'm able to do vector processing very fast in a parallel manner, it is good enough for me. So to keep it as simple as possible, think of it is having 12 different cores of shave processes. And this, by the way, is Myriad 2. Myriad X is already released, that is Myriad 10 or Myriad X, whatever you call it. That contains 16 processors and is usually said to be around 8 to 10 times faster than the original Myriad 2. Just to give the context, but it doesn't matter for us. It's not like that, we need to buy it or we need to create something on it. Technology remains the same, more or less. So that's the hardware part of it. Any question on the hardware part before I get into the software part of it? So this is the hardware which you will see in most IoT. The reason I even chose this is because this was an IoT session. uh, Most IoT device in the world which is performing edge AI is actually using the Myriad VPU. I'm not calling it Movidius because it's a Myriad chip that people are using. Any questions on the hardware part before I move to the you know section for software? Okay. uh, okay then, let's start with the software part of it, right? uh, so think of it that why we even need this, all these hardware, software, new things to bring in for edge AI. The reason is very simple. We want to do it as cheap as possible on the edge. My IoT device is there. I don't want to increase the cost of it by more than 10%, but I still want everything intelligent to happen on it. So what is the best way to do it? You can't use the best hardwares because they are expensive. So what you do is you use the low cost hardwares and make it intelligent. That what we can change in those low cost hardware, that that is good enough for my use case. So by the way, this is there are many applications which uses an Intel Atom chip. I don't know if you guys even know about an Atom. uh, I did see a few Atom systems when I was growing up, but that was also very very young. I don't even know if you have seen Atom chips. uh, but it uses something as old as that, and that is also good enough if we add this VPU capability to the Atom. So think of it that any camera in the world will be equal to or better than an Atom processor being used right now if we use additional hardware. So we call it a hardware accelerator because it accelerates things. So if we are using a hardware accelerator, we know that even in a very low compute or low powered or very old low cost devices also can become intelligent on the edge. So that was on hardware. That is where a lot of places stop right now. So even people using just the mirrored VPU are finding it good enough, and 90% of people stop there. I want to just cover one section of it. The next section that I'm going to cover is actually very, very intense. It is so intense that we have jobs at Intel where people just do development for this. So it is that big a development kit. The reason I want to just cover it for you guys is that if someone of you find it interesting, you can just read about it. Uh, People, you know, uh, there are companies which hires just the Openvino developers. So that's the criticality of it. I remember someone, before my introduction quoted Yanli Kun. Uh, I hope you might know Yanli Kun. He is the, I think, the director of AI or the head of AI at Facebook, and distinguished professor at NYU. If you follow his page, either Facebook or LinkedIn, I think just last week he posted about Edge AI. He posted about Openvino, and he posted about that how it is one of the tools that is being used, and he is looking for people and other resources in his lab to work on it. So I was not planning to add this section before that, because it's even more a higher one level higher. uh, it is not required in most cases, but you can understand from that statement and from such a uh, post from someone so well known in the world of AI, uh, that they are looking into tools like this. So just read about it. Maybe I personally feel that there are well-paying jobs and all those things around there which just uses where your work will be just be a Openvino developer. So it is that extensive. So to start with this is my last section before we move into some demos or questions. Uh, but so what exactly Openvino toolkit is, right? Uh, so if we if we see the actual full form of it, Openvino stands for Open Visual Interference, Visual Inference and Neural Network Optimization. Two important terms here. Visual inference, what I told you about inference is that it is about running your model. Visual here means that again it is focusing on the images and videos related thing. uh, a lot of things that we focus on are mostly images and vision, because that is what is used, and that is where a lot of data is being generated. NLP being the other one, we do support a few things, but most of the tools and most of the work that is happening around the world still remains to be vision. So important terms: vision inference, so this is for running the uh, vision models. And the second part of it, if you think of it, is neural network optimization. uh, I don't think many of us, at least me, when I was in college, I never heard about neural network optimizations, because I think our thought process ends at building the model. We don't even think that if there's anything else after that. And what I found out, and I'll give you examples of what we have done towards the end of it, maybe around a demo, uh, where neural network optimization is very, very important, both in terms of be it the cloud or uh, different applications, and even more important at the edge. The reason being, if now on the edge you are anyway having low processing power, okay, you optimize your hardware so that it can process your AI model, but you still want to improve the AI model in such a way that your accuracy remains the same, but you optimize it so that it becomes faster and consumes less memory. Just think of it how important it becomes when in a IoT kind of a world where there is a resource constraint. Every time in IoT you will have the constraint of resource, you will have limited resources. IoT is also not like cloud where you can just spin another instance, one more cloud you will add, and it can just add you more storage and processing power. This is also resource constraint. So in the world of IoT, it becomes very important that you optimize your model so that the same model with the same accuracy works much, much faster for you on the same hardware. uh, So this is what Openvino does. So I think if you understand visual inference and neural network optimization, this is basically what the work of Openvino is. There are high paying jobs where people are said that, okay, I have this resource, can you make my workload or my model run 10x faster? That's a big challenge. You need to be a big, you need to be an expert to understand that, which mathematical function is taking a lot of time. Can I replace it with something else? Can I remove that layer itself? It's not easy. It takes years of experience, and that's the reason why that, it was never happening till now, because by the time people get so much of experience, they were working on something else. And the newer generation, or at least people with less experience, didn't have the in-depth knowledge to do it. uh, but this is what the tool enables, that, it will automatically do all those things for you. uh, so if you understand the visual inference and the neural network optimization part of it, that's what Openvino does. I'll just take perhaps 5 minutes to cover what are the internals of it, but in a very crisp manner, that is what it is. Uh, so I like to call it as, the AI developer kit redefined. That, it's a developer kit. We are all developers. We used to stop before even thinking about optimizations and uh, deploying our models, but it is redefining how developers used to think. So it's a very important. It becomes a very important component for any AI developer. Uh, so so imagine, a deep learning. You are a deep learning engineer, and you are supposed to make anything for smart cities, and the government gives you the challenge that, you have to run all the models on the edge, because we don't trust any cloud providers. Everything should run on the edge, and only notification should go to the cloud. So you take the challenge, you start working on it, you use a myriad VPU, but now you are feeling that, okay, this myriad VPU is not being good enough, and I'm still getting some latency, which is creating a problem for me. So how to even more optimize it? I can't optimize the hardware even more, because if I use optimize the hardware more, it takes much more time to do so. Or if I use a better hardware, my cost increases a lot. So software comes in the picture right here. Okay, software is usually, when you start working in the industry, will become something which is usually, it doesn't, think of it. Once you develop the software, even if you are plugging it in billions of devices, it is coming at no additional cost. It's not like for every device you'll have to pay money to run your software. That was not the case in hardware. If you want to double the chips, your price doubles, your cost price doubles, so your profit reduces. So that's why the software comes into the picture. So why Openvino? uh, all the computer vision solutions often experience, the bandwidth, storage, and latency limitations. This, obviously, this because that's why we even moved to edge AI. It is very difficult to optimize any vision application to improve performance, and uh, at the same time maintain the, what to say, the accuracy and everything, and then scaling it to meet the power and performance numbers and the cost requirements, right? uh, it is very difficult, and if you don't take care of it, it can become very expensive. So just to reiterate the point I said, that, applying software on different hardware uh, is very much required. If we do it in a traditional sense, it will need both a in-depth understanding of mathematics behind AI, as well as the complete design of our software will change. So both of this thing cannot happen. Think of it, if there are already so many applications running in the world, if I go tomorrow and propose a solution that, what, if you use this software, everything will work 10 times faster, people will not be willing to do it, because they have to change everything. So what is the way that, they can keep using? They don't need to redesign everything. All they need to do is add some layers to it. uh, so that's what it does. Very, very simply. So Openvino has two components internally. So now we are going a little more in depth, just to give you the names of it, so that if one of you are interested, you can always read about it. That's the only intention. I'm not going to tell you how to use Openvino, uh, but if you want to, again, you want to go one step more ahead and want to know that, okay, what exactly is within Openvino that it is doing it. uh, there, Openvino again gets divided into two components. One is the deep learning development toolkit, that is called as DLDT, and second is the traditional computer vision tools and libraries. So it's something like OpenCV, OpenCL, uh, the bit streams, all those things is something you must have already known about. So what OpenVino does is it optimizes everything. So whatever your OpenCV performance is there, it optimizes the matrix multiplication and provides these things by default to you. So the right part of it, right? This part of the screen, you don't even have to touch anything. As soon as you just install OpenVino, it will automatically use the optimized versions of it, which by default is faster. So there are many software professionals across Intel who has worked on it. So that is now available out of the box. So as soon as you install, this will be there by default. So that's one thing they provide. Good part, by the way, the entire OpenVino tool is open source. Any one of you can just go and see that, how it works, what is the code for it, how they are doing it. uh, if you want to contribute to it. So this is the open source tool that makes it even better, that for developers around the world to use it. And it's not about just making business out of it. The second part, which is the more important part, is what we call as model optimizer. So remember, I told you that I can't go and give a solution and tell them that if you completely change your design in some way, it will make it very faster. They will just ask me to get lost, that I'm not doing it. So what we do is we provide something as a model optimizer. What it does, you pass your current models to this, and it will create an intermediate representation. So that is what IR is. Intermediate representation, what do we mean by intermediate representation? So if you remember at the start of it, I told you that every deep learning model or any AI model in that sense consists of two parts. One is the network graph, something like so just the network graph, just think of it. And the other one is the weights and biases. So these are the two things. So if you pass your protobuf file, a TensorFlow PV file, what model optimizer does is it it fetches both those two forms, so which is the XM. So it fetches both your network graph as well as your weights and biases, and make it into a XML. I don't know if you've worked with XML, but it is very similar to JSON kind of a thing. So entire model which you gave, it automatically made it a JSON or a XML. It actually makes an XML, and it makes a bin file. Bin file is the binary blob. So now what, and the reason why it is called intermediate representation is it is in the intermediate form. If you think of it, it is in the middle form. It has been derived from something which will be given to something else. So it gets an XML and bin. So now what it does is, based on all the knowledge base that we have used in the past, that okay, rather than using a matrix multiplication, if we use a scalar or something as such, it will make things faster. So OpenVino already has that knowledge base. So when the developers, when we developed OpenVino, those things are already covered. So without you doing anything, your XML file will be optimized up to a level that if it was initially having 500 different layers, it will identify that how these layers can either be if it can be combined, or some layers can just be removed. So it analyzes everything and sees that some of your layers might not be contributing anything to your accuracy. So what it does is, automatically for your any IoT application, it will make a much smaller graph, but at the same time your accuracy will not be even reduced by 0.01%. I think 10 to the power minus 6, or 10 to the power 6, yeah, 10 to the power minus 6 is the limit that we keep. So 10 to the power minus 6 is what your accuracy will reduce to. That is sixth power of the decimal. So if your accuracy was some 99.000001, it will become 99%. It is not even visible. But what it does is it provides huge amount of uh, acceleration. And I'll show you again what we have done in healthcare, and you will understand the level of optimization that it performs. uh, and then once this intermediate representation is available, right, it is given to something called Inference Engine. So, and then Inference Engine is actually where it runs. uh, this slide is not important. This is just showing one example of how it increases by 20x. It's not 20%, 20x. Think of it that in the time when one image was being think of it in a healthcare scenario. In a time when one scan was being analyzed before, just this software optimization can now do 20 or 20 cases in that same time. So these are all the different ways that people around the world are working on it. so that the problem of lesser compute available on the edge is solved. That even with less compute, will optimize the hardware as well as the software so much that it will become unnoticeable. You will not even notice a difference between performance between when you're running it on the cloud or edge. So the last slide for Openvino, uh, this is the second last, but I think this will be the last slide I will cover on it. uh, so again, 2 points I mentioned: model optimization, optimizer, and inference engine is what is available in this. Okay, so it does two things. It's a very interesting thing, right? I would like you to have a look at it well, have a good look at it. So what it is saying is, you have a trained model. It is Cafe, TensorFlow, MXNet, Caldi, uh, PyTorch, or anything that ONNX support. So you are coming from anywhere, but I can take it and make it into an XML and bin. So now it is creating a standard. So how it helps is, if 10 people in the team uses 5 different frameworks, it doesn't matter to me because it will all be taken as same. The reason I'm saying this is, once you again start working, right, you will know that a lot of people uses TensorFlow in production, whereas PyTorch in research, because PyTorch is very easy to quickly build, but it takes more time to perform the operation. Like it takes more time for that algorithm to run. It's usually slower. It's like C and Python. Python is very easy to write, but takes more time. C is much faster. Similar, you can think of a similar analogy. But now what this mentions is, in whichever framework you are comfortable, you develop it, because at the end of it, before even running, I am going to make everything as XML and bin. So it becomes framework, what to say, now there is no dependency on the framework. So your team is now completely free. You are now completely free to work on any framework, and just then it becomes an XML and bin. Once it becomes an XML and bin, it is similar to Openvino, that it Openvino sees it as similar as all the things are similar, and then it optimizes it. Once it optimizes, it sends it to the inference engine. Now again, very beautiful part here. So at one side, you saw that uh, it was becoming framework independent, that any framework can come. Now it will become platform independent on the other side. If you see it, it is CPU plugin, GPU plugin, FPGA plugin, the myriad plugin. So now, previously what was happening is, how you used to do CPU programming, GPU programming, the FPGA programming, the vision programming, all used to be different. So the developers had that task that wherever you want to run your model, you have to create your application based on that. And it was a big problem, because think of it: you created something for GPU, and later you realize, oh, you know what, a FPGA hardware will be performing better for me. Previously it was very difficult to convert from one to other, because your entire code base has to change to now support the instruction set and everything for FPGA. What Openvino provides it, once you have the XML and bin, it's a configurable parameter. You just write there that so there's a -d parameter. You just write there in the -d whether you want CPU, GPU, FPGA, myriad, or GNA, whatever you mention. Automatically it will run there. So that's the beauty of it. So on one side it is becoming framework independent, the other side it is becoming platform independent. Now you will know that one, it was helping in inference. Second, it was helping in optimization of neural network. And third, it is helping both in terms of framework as well as platform independence. It will give you a very clear picture now that why so many people are very interested in Openvino, or tools like this, and why there's so much of market demand for it. So I'll stop there. This is again more or less talking about the same thing, a little more details, but it is not needed. Uh, I hope everything till this section was clear, at least on the top level. Uh, when we have internal Openvino session, even that lasts for anywhere minimum 2 days to a week, that is 5 days. That is the minimum that is given, but that is internally how it works, how you can run all the codes and all those different things. But I think at least it gave you a good picture of what is happening in the world of IoT and edge AI right now. And you at least know the terms that okay, something like this exists. uh, Once you know the term, if some of you are really interested, you can always work more on it and upskill yourself and get into that niche that only maybe 1% people of on the college level knows those things. So if you have any doubts, please let me know. Otherwise, in the next 15 minutes, I'll closely show you a few examples, and then we'll close it. Don't know if this is this visible? Is the command line visible?
Yes, Mashrin, it's visible.
Yeah. So if you think here, right? So your interactive face detection was the application name. Then you are just doing a slash m. Slash m means the model. If you think of it, this is there where you are giving us .xml path. So .xml path knows that where is your optimized graph. Once that is there, you give a hyphen I. Hyphen I basically means what is your input. It can be a real-time camera or a video. In this case, it is a video. That's why MP4 is there. And after that, you can use a hyphen D and give which platform you want to run it on, CPU, GPU, mediated, or whatever. By default, I think it takes CPU, and that's how it runs. So you see it, right? That how easy it is to now develop. That you don't have to do anything. You just need to know how it works and what is the best practices of Openvino, and at least you can become an application developer just by knowing that. And you are then contributing big things to the companies you join, because to them it will be magical that how you are able to achieve the same things 10x faster on the same things. And very honestly, all you are doing is that you know one tool and you are converting it. That's it. If you want to get more in details, then you should actually become an Openvino developer who is actually doing everything internally, which lets you do this. So this is just to show that how easy it is that you're just passing flags and doing it. uh, One example of it, right? This is done by our team. To show Okay. So this is done by our team with Philips. Uh, this is, I think, available online. So that's why I can show you this data. We have a lot of optimizations that we do, which we don't have it publicly available. But if you see, we worked with Philips for our healthcare product, and we did, we optimized two of the models together. Okay. Uh, and these two were that one is the bone age prediction. What bone age prediction does is that based on your bone density and everything, it will predict the age. uh, if the age is coming out to be more or less your real age, everything is fine. If it is less or high, then you are either aging faster or slower. Then there are different diseases that can be detected based on analyzing whether you are growing faster or slower than usual. If you are growing very fast, there are certain diseases that can happen, so doctors can have a look at it. The second one is more or less the lung segmentation. This was used for lung cancer detection and all those things. So it segments the lungs and then finds it. So if you see the numbers, right, the numbers will be astonishing. So 188x and 38x. So in the time when the hospitals were using this model to run one image or one case, we did 188 cases, and this was just the power of a software. We did use some internals of Openvino as well. I don't think just by using the application you will get this. Uh, but even that is good enough, right? And this answers your questions that the limitations of edge can be covered, that gap can be filled if you smartly optimize your hardware and the software. So 188x or 38x, even 38x is not a joke. Think of it, a hospital can now do all the things 38 times more, uh, like in the same time. uh, this is also true for any IoT cases, right? A lot of people now even thinks of hospitals as IoT because those are different nodes available just with them, uh, and connected to the internet. So we do everything on the edge, and this is what we achieve. This was just to give you a perspective on what can be done. There are enough resources online. This entire tool, the sample applications, everything is open source. There are top researchers who has posted on it, so you can read more about it, and they then you will be able to cover much more than what I can just tell you in these 2 hours. But this was just to show the power of it, that 188x or something on that magnitude can also be achieved. Uh, okay, I think I'm more or less done. I'll show you one video. uh, Sorry, I'm not in campus. We're all working from home for the entire year, uh, till June next year actually. So we don't have any. I don't have any real hardware right now at home that I can show you. But I can show you a video which I uh, did with the Amazon AI Conclave. So this was the Amazon AI Conclave that was there. So we did a keynote there because Amazon is also like the Amazon is one of the Intel partners, and they use these things in a lot of their devices. So we had a keynote session there. So I, along with couple from Intel, we gave a keynote session on it. So I'll just show you the video for that. I'm sorry, that's the best I can do right now because I don't have any hardware. I hope it clarifies a few things. I don't know if it is audible, uh, but let's see. Please let me know if someone can hear it. Figure out in a retail environment, say for example, what is the event? Was it audible? Did you hear any?
Yes, it's audible.
Okay, thank you so much. So just listen it to for 2 to 3 minutes, right? I'll not run the entire video. Uh, you will get what I'm trying to say, the sense of it in the first 2 3 minutes. Then I'll speak for another 5 minutes and we'll close it. Thanks. Just have a look. You will get the. I think this will cover everything that we have covered so far. So if you point it to a set of monitors, it can tell you that there are 3 TV screens present here. If you point it to a set of 10 water bottles, it can help you identify the except a bottle of Coke near one. Sorry for the issue that we faced. So here, basically, what we're trying to show is a retail store example where everything we want to run on the edge. So if you see here, this is we are completely disconnected through the internet, and we are doing the inventory tracker. So be the number of people, the milk bottles, the TV screens, or onion. These are 4 things that what we have trained our model on. One important thing to remember before we go into the demo is it's not about how well the model is performing. We are presently demonstrating the accelerator that we have. It's about how powerful that inference accelerator is. As Oliver mentioned in his keynote as well, 90% of the cost spent is on the inference and not on the training. And we are showing how Movidius, the MCS, can help in the inference part of it. So in this example, what I'm trying to do is to create a bottleneck, a complete bottleneck, because if you want to understand the power of a hardware, let's create a bottleneck and then see how well it is performing. So I'm running this on an Intel NUC and with a Celeron processor. Again, I am using an HD camera. On top of it, I'm running it on a node server. So trying to overkill it in all the ways and then see how well the inference is performing. So in this case, the model which is retrained is MobileNet SSD. We have used Intel Python, which by the way is free and is much more faster on Intel architecture than Python that we use. Another tool that we have used is something called Openvino. So what Openvino does is, it internally has 2 components. One is the Intel computer vision, and the other one is BLDD. And basically, you bring your models in any framework, be it TensorFlow, Caffe, or MXNet, and you want to deploy it on any platform. Perhaps it can be a Xeon or a Movidius NCS, the VPU, or the GPUs as well. And how it can help is, so it internally converts it into an intermediate representation. So you have so it becomes completely independent of the framework that you use and the platform that you want to deploy. In this example, you'll see so basically I am counting the number of people that I can see in this with the number of TV, for example, and the number of bottles. So basically what is happening, there's a PI running in there where the store owners can see, based on the number of people that is entering their store, how the inventory is changing, and based on that, how the customer versus revenue thing is being generated. And based on the tracking of the inventories that is there, perhaps when sales is low, We can then ping the cloud and connect any APIs that, okay, the TVs have reached a low order. Let's, bring some more to the inventory. So this is one example that we're running completely on the edge. And most important thing that you see is how good the FPS is, even on a Celeron and with just the NCS. So all the processing is happening on the NCS, except for transmitting the camera frames to it. So that's basically what we wanted to show. Thank you. Okay. Just to reiterate, so this is the demo where we used all of it, right? Be it Openvino, where we optimized it, as well as NCS, where it ran. Again, as I mentioned in the in that session as well, that it's all about how fast it is running. So if you noticed that, I don't know if there was latency because of Zoom, but I tried to create all the bottleneck. Uh, there was a HD camera running on a very low powered uh, NUC. At the same time, I ran node applications and all, which is usually uh, known to be slower, but it did perform well even there. So this is powerful, and that was just one use case showing that uh, how how in different use cases you can always optimize your model and do it. That's it I have for the session. I think in these 2 hours, that's all we could have covered. So I tried to keep it as short and simple as possible. If you have any questions, feel free to connect on LinkedIn or anywhere as such, and I would be happy to answer if you have any questions. That's it from me. I don't